So now to write a fraction in simplest form, we write the prime factorization of the numerator and denominator and divide both by all the common factors. So prime factorization takes a little bit of time and energy and effort to get used to and get comfortable with, but it is definitely worth it if you're going to be in math classes. It will help you, really in the long run, it'll help you a lot. So we're going to look at 63 and 99, and when you say prime factorization, you're taking the number and you want to write it so that all of its factors are prime. All the numbers that multiply to give you this number are prime. Okay, so you really just want to start breaking it down into numbers that multiply to give you this number. So we have 63. There's a couple different places you could start. You could start at 3, or maybe you remember that 9 times 7 gives you 63. 7 is already prime. Prime means that the only numbers that multiply to give you that number are 1 and itself, right? For 7, there's nothing multiplied by something else that gives me 7. So 7 is prime. 9 breaks down into 3 times 3, okay? And 3 is prime. So now our prime factorization of the numerator is the negative is out front, 3 times 7, okay? And then we want to take 99 and do the same thing. And then we want to take 99 and do the same thing. So hopefully you'll see 9 and 11, right? That's a pretty common one for a number. When it's repeated, it's usually times 11. So 11 also is prime. It's only got 1 and 11 to get 11. 9 breaks down to 3 and 3 again. So now I have 3 times 11. Okay, so if I rewrite this, I still have my negative out front. And now I want to look at what is in both the numerator and the denominator, and they both have a 3. So I'm going to divide out a 9, because 3 times 3 is 9. I'm going to divide out 2 3s, which would be 9, right? Because also anything over itself is equal to 1. So it very easily, you can see, equals to 7 over 11. If you do prime factorization, it makes it a lot easier to do this simplification here where we can just cancel it out, because any number over itself is equal to 1 when you're talking about a fraction. So you would get 7 over 11. Also, you have this negative sign out front, right? We want to not forget that, and we want to make it negative 7 over 11. It's a very easy place to make a mistake, a very common mistake to make. Unfortunately, my math lab is going to be checking for that, and it will mark you wrong if you just even miss the negative. So please make sure you're going slowly, taking your time, checking the question, make sure you wrote everything down, all of that stuff. So looking at 26, 12x squared over 18x. So 12x squared, we're going to do the same thing where we break it down. Hopefully you remember 2 times 6 gives me 12. 6 breaks down to 2 times 3. Okay, so that means my numerator is 2 times 2 times 3 for the 12. And then I also have an x squared. If you remember the definition of an exponent, it means it times itself, right? So x times x. And then I have 18x. So I'm going to break down 18, which is 2 times 9. And 9 is 3 times 3. So my bottom is 2 times 3 times 3 times 1x, because there's 1x here. Again, with prime factorization, once you do all the factorization, you could really just say that anything over itself will cancel out. So 2 divided by 2 would be 1. 3 divided by 3 would be 1. And x divided by x would be 1. And I could write down what is left. 2x over 3 would be my simplified form. My math lab will mark you wrong if you do not have the most simplified form. So even if you do all the other steps right, but you forget to simplify and divide out whatever is common, then you will get it wrong, okay? So to multiply two fractions, multiply the numerators and multiply the denominators. To divide two fractions, you multiply the first fraction by the reciprocal of the second fraction, write the product or quotient in simplest form. Right, so for division, a lot of times we say keep, change, flip. We keep the first one, we change to multiplication, and we flip the second. So the first problem they give us, negative 5 divided by 3 times negative 3 divided by 29. So it says to multiply two fractions, multiply the numerators and multiply the denominators. So I'm going to do negative 5 times negative 3. Negative times a negative gives me a positive 15. And then I have 3 times 29. So you see I pulled the negative up to the numerator. It was out front. That's okay as long as I only pull it to the numerator or the denominator. I cannot make them both negative. That would be incorrect. So I can make the numerator negative or the denominator. So negative 5 times negative 3 gives me 15. Now 3 times 29 is 87. Okay. So now I have 15 over 87, and it says write the product or quotient in simplest form. So 15 over 87, we need to make sure that it is in simplest form. Okay, so even though it looks like maybe nothing can come out, we need to check to make sure it is in simplest form. We can use prime factorization, or you can use numbers that you already know that go into it. Right, 15 only has 3 and 5. So we could take 87 and check to see if 3 or 5 goes in. Well, it doesn't end in a 5 or a 0, so 5 doesn't go in. But 3 times 2 would be 6, which would give me a 2 here. Bring down my 7, 29, right? Which is actually what we started with, because we could have simplified crossways here if we wanted to. But instead we're going to divide the top and the bottom by 3 after we multiplied, which would give us 5 over 29 would be the correct answer. If you answered 15 over 87, you would get it wrong because it's not in simplified form. Negative 3 over 4 divided by 3 over 8. So this is where we're going to use keep, change, flip. We're going to keep the negative 3 over 4. We're going to change to multiplication, and we're going to flip the 8 over 3. And now we can multiply like we normally would. Okay, so you do negative 3 times 8 gives me a negative 24. Divided by 4 times 3 is 12. And hopefully maybe you see that these are actually factors of each other. So this actually divides evenly into negative 2. Again, this is the correct answer. If you answer this, MyMathLab will mark you wrong because it's not the simplest form of the answer. To add or subtract unlike fractions, find the least common denominator of the fractions, and then write each fraction as an equivalent fraction whose denominator is the least common denominator. Then you can add and subtract the like fractions. So what you're saying is I need to be talking about the same thing, right? I need to be putting it into an amount that is equivalent so that when I'm talking about changing it out, it's the same, right? If I have this and I cut it into fourths, and this into thirds, these are not talking about the same size thing. So we need them to be broken down into something smaller that they could both represent. Okay? So we look at the two fractions at the denominators. In this case, it's 8 and 9. And what we want to do is find a number that they could both multiply to. It's always got to go up unless one is a factor of the other. That they could both multiply up to, right? This just takes some time to get used to. So you could try, like 8 times 2 is 16. Well, 9, it doesn't go into 16. 8 times 3 is 24. 9 doesn't go into 24. 8 times 4 is 48. 9 doesn't go into 48. 8 times 5 is 40. 9 doesn't go into 40. 8 times 6 is 48. 9 doesn't go into 48. 8 times 7 is 56. 9 doesn't go into 7. Or 9 doesn't go into 56. 8 times 8 is 64, which 9 doesn't go into. So then you just have to do 8 times 9. So you have to literally multiply them by each other. So you can always get a common denominator this way. But it may not be the least. Sometimes it is, but it's not always the least common to multiply the two times each other. This time it is, so 8 times 9 gives me 72. What I'm going to do is multiply this fraction by 9 over 9 because I'm trying to get the denominator to 72, and this fraction by 8 over 8 because again I'm trying to get the denominator to 72. And anything over itself is equal to 1, right? If I have $9 and I'm going to split it up between 9 people, each person's going to get $1. 9 times 7 gives me 63 over 72. Plus 2 times 8 gives me 16 over 72. Now when you add, you only add the numerators. The denominators stay the same. And we add the numerators, so we get 79. Right? And we want to check to see if there's anything that comes out of both. They're not both even, so it's not going to be 2, but I would try 3 just to see does 3 come out of each. 3 goes into 7 twice, which would give me 6. And then that gives me 19, which is not divisible by 3. So 3 does not come out of both. You could check 4, but 4 does not go into 79. 5 does not go into 79. 6 does not. 7 does not. 8 does not. And 9 does not. So at that point, you're pretty good. You've checked for most numbers. I'm not saying there's not a chance there could be another number, but most likely that is the answer. Same thing here. Now we have 10 and 15. The other way to do an LCD is to do prime factorization. So if I do prime factorization, I get 2 times 5, and I get 3 times 5. Right? So I want to look at 10 is equal to 2 times 5. 15 is equal to 3 times 5. And I see that they both have a 5, so my LCD is going to have a 5. Okay, and then it's also going to have whatever else is here. It's going to get 1 5 because they both have 1. And then you're going to do times 2 times 3. So 5 times 2 is 10 times 3 means my LCD is 30. So this is a little bit more of a methodical approach versus the other way was kind of just trial and error. So now I want to get my denominators to 30. I have 7 over 10 minus 13 over 15. What times 10 would give me 30? 3. And what times 15 would give me 30? 2. So 3 times 7 is 21 over 30 minus 13 times 2, which is 26 over 30. Again, just like I only added on the top, I'm only going to subtract on the top. So it's going to be over 30. 21 minus 26 is 5. Okay, so 5 is prime. It's 5 over 30. The only thing I could take out then is a 5 if 30 was divisible by 5. And it is because it ends in a 0. If a number ends in a 0 or a 5, it means it's divisible by 5. So I'm going to divide 5 out of the numerator and 5 out of the denominator. I have to divide the same thing out of both the top and the bottom. 5 divided by 5 is 1. 30 divided by 5 is 6. So my answer here would be 1 over 6.